Okay, good morning, everybody. Bright and early today. All right. A couple of things. So we're gonna. I know we finished the slides on ER modeling last time on the video that I recorded, but I did want to go ahead and go over that specialization section one more time, only because it's important to understand, and really the understanding of how these different diagrams and how how the relationships interact is very important, because when it comes to the next part of what we're going to start talking about in terms of designing, in terms of normalization, in terms of other things for actually getting from the design, the conceptual design of a database, into the actual physical design later on, uh, making sure that we understand how these things should be interpreted, how the diagram components should be understood, is very important for us to be able to accurately, correctly develop the database itself once we get there. Um, but first, there were some questions. Apparently, there was some issues with the quiz. Seems like, uh, last week for another class, I gave a quiz, and half the students couldn't even get the link to work. So it seems like as much as we've got advancements in technology, we're still having some issues. So what I'm going to do is this. For anyone that contacted me during the quiz or immediately after, or if in your submission you wrote in the text box, hey, I can't see this, something like that, something, I can't see the diagram, or the diagram is not visible, just something to let me know that you tried to answer the question, you didn't just leave it blank, that you tried to do something and you said, hey, this isn't working, I don't understand what's going on. So indicate to me in that some way. So either, like I said, as part of the text box, during the quiz, or immediately after, to say this was not visible. Then what I will do is I just won't count that part. So that was 18 points out of 50 points. So what will happen is your quiz will just be out of 32 instead, and we'll only grade the first 32 points, and not so you won't get any points, but you won't lose any points. So it's kind of like it works out. All right, you weren't able to do it, so I can't grade you on it. All right, but expect that for anyone who was able to see that diagram, or I will go ahead and what I'll do is I'll post it. I'll post the picture here so you can at least know what I was asking. And the reason for that is because you can expect that something like this would show up on a midterm or final exam. That I would definitely want you to be able to analyze a diagram and be able to tell me, what do you understand from this picture? What do you understand from this diagram? And if all that you say is, like, if you see a relationship between two entities and all that you say is there's a relationship between the user and the app entities, and if that's all you say, if that's all that you understand about the diagram, you can expect you won't receive many points for that, because that's not all that was there. It was telling us a lot more than just that there was a relationship that existed between the two. It's telling us what type of relationship. Is it many to many? Is it one to many? Is it one to one? What about participation constraints? What about, does the user have to participate in the relationship? Does the app have to participate in the relationship? Okay, so these are things that we can learn from just looking at the diagram, and I went over that in class. And so so that's, expect that you would be able to tell me a lot more than just two entities have a relationship between them. Okay, all right, so like I said, I want to go back over the superclass subclass stuff. All right, so remember that this comes from UML. All right, this is for those of you who remember UML. Hopefully that's all of you, but I also understand that that may not be. So for UML, we had this whole idea of a subclass and superclass relationship that could exist. And in Java, you did that with the extends keyword, where basically the idea was that you had a parent class, a parent ebevin, right? You had a parent class and a chojuk class, right? A child class. That everything that the parent has, the child inherits that. So if the parent had attributes, the child inherits that, or at least inherits, well, if they're private, okay. Methods, public methods especially, was what we were mostly concerned with there. All right, but anything that a parent has, a child just automatically gets it. All right, now we can override it in the UML, in object-oriented programming, right? But you understood, I hope, the idea that what we were trying to do is we were trying to say we want to create a generic class for a certain type of thing, like person. Right? You might have person class. You might have what else? You might have a school, right? You might have a school would be a generalization. It would be a parent class, and then a type of school. Like you might have a private school, ozelokul. You might have a public school, a devletokul. You might have a university is a type of school, right? And each of those has some differences, right? And those would be the subclasses. Okay. So let's just get into how we do that in a database. So the way we do that in Java, it's pretty easy. You just do the extends keyword, and suddenly the child class gets everything from the parent class. That's pretty easy, right? The problem is in database, it's not as easy, and we'll see that once we actually get into actually implementing the database later. Okay, so the idea is the same as in UML, specialization and generalization. So again, this was the example we talked about, I showed on the video, where you have certain attributes here, certain attributes that are common to all, certain attributes that are specific for certain types of staff. Okay. All right. So this might be how you would show that. Now, the staff part here, this, let's see here. I want to do that. Okay. So if we look here, what we're talking about is we're really just talking about the staff table, right? The staff entity. So really that previous slide is really just covering this stuff here. All right. That's really what it's covering. This branch thing over here, this branch thing over here is a different entity. Okay, it's not part of that branch, but because the staff has a double relationship in our original situation, the staff has a double relationship where branch has staff and staff manages branches. All right, because of that, we decided to include it as part of the diagram here. But the main stuff we are focusing on for this discussion, as far as this slide is concerned, is this part right here, just these three entities over here. Okay, so what we're saying is that staff, right? There's certain attributes that are common to all staff people, all people who work for our company. There are some attributes that are specific to managers. There are some attributes that are specific to sales. There are some attributes that are specific to secretary. Okay. Now notice that the branch does not have a has relationship with all three of these. Like it's not an individual relationship. Branch has manager, branch has salesperson, branch has secretary. We don't have to do that. We can just say that the branch has staff, right? And we can just say, hey, it just has staff. Now we don't care so much what type of staff they are. All right, we just know that the branch has staff people. Okay. In a sense, if you think back to your object-oriented days, to your Java programming days, which hopefully you're still writing Java code when you get the chance. But if you remember back to that, remember we could create an array list, or any type of collection that had the parent type, even if it was abstract, right? We could have an array list of staff, and we could put managers in there, and we could put sales personnel in there, and we could put secretaries in there, right? So this is like that same thing, where we just want to keep a collection of, for each branch, we want to have a link to keep a collection of all the staff people who happen to be in working at that branch. Okay. But if you think back also a few slides before, where we had the setup with the staff branch, before we had all of this stuff down here, when we just had the branch and the staff, and that's all we had a second relationship between staff and branch, right? You remember maybe it was a manages relationship, where a certain staff manages a branch. Now remember, that was a one-to-one relationship. Let me see if I can find that slide actually. So fine, not there. Let's see, 26. Here it is, right here. Right. So this was this relationship where the staff manages a branch. Now, remember, we talked about this type of relationship. It was a one-to-one relationship with participation being mandatory on the branch side. And the reason why was because we said every branch has to have a manager, right? So no matter what, if a branch exists in our system, we have to have a manager. But the reason why participation was not required, why we had this 0 here on the staff to the branch side, the reason why participation is not required by staff is because not all staff are managers, right? So we would have to say, okay, we need to have this relationship where a branch is managed by a member of staff. A staff can manage a branch, all right? That's the one over here, but does not have to, because not all staff are managers. That makes sense. All right. So let's take a look at our new version of this. Okay. Now, instead of having a one-to-one relationship that has optional participation by the manager, now we can have a one-to-one required participation relationship here. And basically what we're saying is that if a staff person gets promoted to this position of manager, if at some point they get promoted to this position of manager, they must manage a branch. We don't have managers that don't manage branches. And so now by expanding this diagram a little bit, we've given some more meaning to the diagram. That previous relationship might have said, okay, so a staff person can manage a branch, and a branch has to have a staff that's managing it, but we didn't have any kind of special requirement on that. We could just choose any random staff person, right? We didn't say that the person in the staff entity had to be a manager, had to have the role as manager. We just said we didn't have that requirement on the previous slide, right? We didn't have that requirement here. There's nothing in this requirement that tells me what type of staff this has to be. Okay. Whereas here, now I'm able to say that person that's managing the branch there has to be a requirement on who they are, on what type of role they have. Okay. All right. The other thing I pointed out that I wanted to talk about, because this is another thing that can get kind of difficult to understand, is this optional and. Because we didn't have this notation in UML, did we? We didn't really have this when we talked through this in Java. All right. Optional and. So optional simply means that being a member of the child class, being a member of the subclass is optional. It's not required. So what that means is we could have people who are just staff. We could have people who are staff people who are managers. We could have people who are staff who are secretaries, people who are staff who are sales personnel. Right? So optional, I can be a member of the subclass, but I don't have to be. So the way to understand optional is to understand that since they can be just a member of staff, they don't have to be a member of the child classes, they can be just a member of staff, then staff in this case would be non-abstract. If you want to go back to what UML and Java when we talked about abstract classes. So staff is a non-abstract class. Someone can be just a staff person. An object, right? So an instance can be just a staff person. Okay. The and here is telling me that I can be more than one of these things. I could be a manager and a sales personnel. I could be a manager and a secretary. I could be a sales personnel and a secretary. I could be all three. Mm-hmm. Now, someone who is a manager, sales personnel, and secretary all together in one person would be kind of weird, right? I'm not sure I've ever seen that happen in real life, but our system, in order to be able to allow someone to be more than one of these things, we have to be able to allow them to be all of them. I mean, it could happen in the system. Probably wouldn't, but. So the and means that it can hold multiples of these. Okay, and that's something that we did not have in UML and Java. Right, we did not have the ability for a class, for an object to be multiple children. Right, if we wanted to represent somebody who was a sales manager, we'd have to create another class called sales manager. Right? So, or we'd have to make one of these. We could start talking about interfaces, but that's too confusing, right? So, optional, I can be just a staff, I can be one of these, and I can be any one of these or more than one of these. Okay. So then a question that comes to my mind is, okay, since the and exists, can someone be just a staff and a manager? Since you're saying he can be and, can he be a staff and a manager? What do you think? What would that, does that make sense? Right, Furkan, that's right. I'm assuming do you go by Furkan or Fatih? I don't. Anyway, uh, yeah, a manager is a staff. So just by someone being a manager, they already are a staff. All right. Remember that the way that this inheritance stuff works is if someone is a manager, they inherit all of these attributes from staff. Right? They get all of those. Right? So by the fact that the manager is a staff, he or she already has that. Okay? So in a sense, and means yes, they can be a staff, but that's because manager is a staff, or these child classes, these child entities are the parent entities as well. Okay, they are, that has an is a relationship. Okay, all right, let's move on because there's another thing I want to talk about is this concept of mandatory or. So if we have optional and, the opposite of that would be mandatory or. Now, opposite on both fronts. So this, don't think of this as optional and go together, and don't think of this as mandatory or go together. These are two separate things. Okay? Optional is on its own, mandatory is on its own. There are four possible combinations. You could have optional and, optional or, mandatory and, mandatory or. Okay. Simply what optional means is I can be just this, or I, you know, or I can be one of these. Okay. And means I can be more than one. Okay. So or mandatory or for both of those characteristics would be the opposite. Mandatory means if I have someone who's one of these, then I must be one of these. Okay. So the way to think about this from a programming Java UML perspective is this would make this the parent entity like an abstract class, meaning if you had one of these, you couldn't just create an object of that type. You would have to create an object of the subtype. Right? And this is where this becomes very different from UML and Java, right? Because in UML and Java, we could not have a class that was both abstract and non-abstract, right? You couldn't define the class to be abstract for certain things and non-abstract for other things. Like you couldn't do that. But here, we're defining each parent-child relationship, each set of parent-child relationships to be their own thing. So this one is optional, meaning staff operates like a non-abstract class in this situation. Here on this side, the full-time versus part-time is mandatory. So this relationship makes staff act like an abstract class, meaning we can't have someone who's just a staff and isn't one of these. All right. So we have a staff who must be one of these. Okay. And the or, as I said in the video, and I'll say it again, or does not operate as logical or in this situation. It operates as logical exclusive or. And what that means is that if I have an instance of one of these, it cannot be an instance of the other. Okay. And oftentimes, the names of our entities will even help us understand what type of relationship it should be. Should it be an and? Should it be an or? So for example, here you have a full-time permanent staff. Here you have a part-time temporary staff. And it would make sense that you cannot have somebody be both full-time and part-time working for the same company. I mean, that would not make sense. So or means if I am one, I cannot be the other. If I am not this, then I must be one of the others. Okay. And this doesn't mean that you have to have only two child classes here, two child entities here. You could have 3, 4, 5, however many you want. If you put the or on there, though, it simply means they can be one of those and none of the rest. So if you have 20 subclasses here, subtypes on the entities, and you have an or as part of that relationship, then what that means is that if they are one of those 20, they cannot be any of the other 19. Okay. All right. So that's optional and, mandatory or. Is there another? Okay. We also have an optional and. Oh, sorry, we already did that, didn't we? Optional and. That makes sense. We also have, oh, sorry, here's what I want to say, was if a child exists and it's the only child of the parent, then there is no need for the and or the or, right? Because there's no other options, right? And or over here only makes sense when there's multiple options. If there's only the one, assistant secretary in this case, then we simply say, is it optional or mandatory? All right. And I would say it does not make sense for this, if it's like this type of relationship, it would not make sense for this ever to be mandatory. And why do you think I say that? Why do you think that I say that this type of relationship, a single parent with a single child, being optional, is the only thing that makes sense? That mandatory would not make sense in this situation. What do you think? Yeah, exactly. If it's mandatory, let's say assistant secretary was mandatory for some reason, then why would we need this child class at all? Why not just take everything of here and put it into this class, right? Because if it's mandatory, it means that this must be this thing. It must be this child. The child has all the same attributes as the parent plus their own, which means really we just combine the two into one class. Okay. Here, another thing that we are allowed to do that we weren't allowed to do in UML is we can have children that are subclasses of the combination of two classes. So here we have the manager and the sales personnel combine to make a sales manager. So this would be a child that would be both a manager and a sales personnel. And this type of relationship, this being able to join the two together like this, would not make sense if this was an or, right? If this was an or, then we could not combine the two because someone can't be both. They would have to be one or the other. All right. So we talked about the participation and disjoint. The four different options here: mandatory and disjoint, optional and non-disjoint. Those are just terms that are based on the mandatory and optional and an or, right? Okay. Yeah. So disjoint would mean or, because they'd have to be one or the other. Non-disjoint, meaning they can be more than one, would be the and. Okay. So some other examples we talked about. Here we have an optional or, meaning a staff person could be a manager, could be a supervisor, but if they're one of these, they cannot be the other. Okay. Mandatory or, we had an example of that before. All right. I think optional or, an example of that there. Okay. All right. So that concludes the ER diagram. Okay. That concludes the ER discussion. And you know what? Before beginning the normalization discussion, let's go ahead and have our break now, unless there are other comments or questions that anyone wants to make. If anyone has a kind of question or comment, we can do that. But if not, then we'll take a break and then we'll do, excuse me, then we'll do normalization after the break. All right. So we'll start up again in 10 minutes and we'll begin normalization.